Okay, sorry about that. Sorry for the delay. So this week's code of conduct is to speak next quarterly of ECI as accompanying our workers. This is a real good code item for just kind of, promoting the community that we're trying to build here at Engineers to continue to work together to look out for our best interest. When someone's down, let's raise them up. Let's really look out for each other out there. So safety news, excellent. Another week, 141 days. We're really on a good trend. Let's just keep it up. Let's keep following the code items. Let's keep doing what we're doing. We're doing an excellent job out there. So let's just keep it up. So we're going to continue our rigging and hitching of all of our month of September. Just kind of rigging awareness. This week we're going to talk a little bit about the bridle. As you can see here, the bridle hitch is really when you've got a 2 to 3 to 4 legs off of main hoist, and it's kind of a direct connection to what we're picking. So some of the would be like a trench box, would be a manhole, some of our structures, things like that would be that type of hitch. So we're going to go over some of the important parts to look for. A lot of it is our angles that we have, and there's a video by Crosby, kind of like we watched last week, but this week's going to be a little bit different about just the best practice. And I think Ken's going to talk a little bit more in depth in the technical tip. But some of the things is how we reduce our angles, what types of tension and stress it puts on our rigging. So we've got a little video here.
The rigging triangle is a key consideration when making connections to loads and load hooks. The rigging triangle is formed anytime 2 or more slings are connected to a load and load hook. Whether the slings are chain, wire rope, or synthetic, the best practices are based on the same principles. Focusing on the horizontal sling angles formed in the rigging triangle highlights several best practices that are very valuable to the rigger. It is important to remember that as the rigging triangle becomes flatter, the horizontal sling angles become smaller. As the horizontal sling angle becomes smaller, even though the lifting load remains the same, the crushing loads increase. The sling tension is the result of both lifting and crushing. This means as the sling angle becomes smaller, the sling tension and the load at the load connections increase, and the crushing forces pulling the slings toward the COG also increase. The result is that at 60 degrees horizontal sling angle, the sling tension is multiplied by 1.15. At 45 degrees, the tension is multiplied by 1.41. And at 30 degrees horizontal sling angle, the tension is multiplied by 2. These facts lead us to recognize the best practice for selecting proper sling angles. For multiple leg bridles, whether the connection is direct to the load with hardware or choker and basket hitches, a horizontal sling angle of 60 degrees is the angle of choice. This is because the multiplier is only 1.15, the side or angular load on the load connections is limited, and the crushing load is minimal. A tool to use to verify that the slings are rigged to 60 degrees is to remember that a 60-degree sling angle is formed when an equilateral triangle is created. That means that the sling lengths will be equal to the distance between pick points. It is also useful to remember that increasing the sling length will increase the horizontal sling angle and improve the rigging situation. It must be noted that 60 degrees horizontal sling angle is the best choice, but is also the minimum angle for single wrap chokers and single wrap baskets. There are circumstances where a 60-degree horizontal sling angle is not possible. When this occurs, there are guidelines for the minimum sling angles that can be used with extreme care. 45 degrees is an acceptable horizontal sling angle only for bridles connected hardware to hardware and for double wrap choker hitches. At 45 degrees, the sling multiplier increases to 1.41 times. The crushing forces pull the slings toward the load center, and the angular or side loading is very significant. 30 degrees is never a desirable angle. However, 30 degrees horizontal sling angle can be used with extreme care when connecting hardware to hardware. Never use choker or basket hitches at this minimal angle. Remember, best practice calls for a horizontal sling angle of 60 degrees or larger for all connections and hitches, basket or choker, single or double wrap.
So, any questions regarding that video? There are a couple key things I wanted to point out. When we get lower than 60 degrees, we're not allowed to use our choker hitches or our basket hitches. Okay, it's supposed to be some kind of using shackles. You're actually hooked to what we're doing. We're allowed to do those double wrap chokers that we talked about last week at 45 degree angles. So those are some of the things that you can think about when you're planning your picks out there on a day-to-day basis. You got to really think about making sure we're trying to keep everything to that 60 degree, where is it on the map? But the 60 degree angles, and the best way to do that is by laying both of your rigging components over each other's pick point. If you have that overlap, you're going to have that 60 degrees. That's the easiest thing to do out there in the field as riggers. Just making sure we're maintaining that 60 degrees. If we can't do that, know that we have more stress, so we've got to make sure we beef up our rigging. If you got any questions, call. We can walk you through that. I also have some really good wallet size stuff that kind of explains a lot of that stuff, a real rigger handbook. If you want any, come see me and we can kind of go through that rigger's handbook. Is there any questions regarding the bridle hitch or any rigging we have out there? Thank you.
Thanks, Matt. We're going to apply some of our trigonometry here. Okay. First, corporate announcements. We have a new employee, Alan Michael Du Bois. Actually, I guess probably that hyphenated there. Where's Alan? Are you here, Alan? Oh, okay. Hi, welcome, Alan. Okay. And ECI celebrates Alan's 80th birthday. There we are out by the office in front of the cake, delicious cake that Alberta made with cupcakes. And we had perfect weather for it, as we got some great weather coming forward here in front of us. So here's a promise I made about the geometry and trigonometry and resolving forces and using it for figuring out some of this. The nice thing about it, you go to a Crosby or the Haynes book, charts are right there, tell you what to use. But the thinking behind it, and sometimes we have to get more in depth, is looking at trigonometry and see here's all the baskets that you might consider with. You always, of course, want to go to the 60 degree. So again, if you take the length of your sling and you lay it down, you should be beyond that other pick point or at that other pick point to get you 60. So these are more specialized cases that you get special considerations for. And this is obviously not a great one either because your load's not really stabilized, not at all. So I use the example here of a 45 degree basket, which is more than we want, but the tangents and the cosine and sines are easy to deal with and to demonstrate the point. So what you got an object. In this case, I use 1,000 pounds because it's a nice even number and we can break it down easily. At 45 degrees on each of the basket legs, and what you got is you see you have to look at what's called the equilibrium or the balancing out forces. And you get that point there. If you got a tension, well, first of all, let's go with the weight. You get the weight, or half that 1,000 goes to that leg if it's, if it's even. And then you've got a tension load in your sling. Well, you've got an offsetting force to resist that tension load. So that's where where you look at these balances of forces, and in this case, in the y direction, or the vertical direction, and you calculate it out. So the 500-pound load is balanced by the vertical component of T of that sling capacity or force, and the horizontal component of the 45 degree must be balanced in the other direction. So see, you got a tension here. Well, something's got to push back. So we can just use straight geometry and trigonometry to figure all that out. And it turns out that if you add, let's get that view here. If you say all the forces in the y direction are equal to resist each other, or equal and opposite, you have that minus 500, I'm calling minus down, plus the tension in the sling and the component vertically. You can resolve that using the sine of 45 degrees. You get 707 pounds. So basically, the tension in that for a 1,000-pound weight is 707 pounds, which is what they show in that little chart. Oops. Right here, 707 pounds. So you can break that down if you have to figure out what your actual sling loads are. Like I say, the charts do this, but sometimes you have to understand what goes into the charts. And then on that crushing load, we can add the forces in the x direction, the horizontal direction, and there's a tension in the sling, and we take the horizontal component by having 45, the function 40 cosine of 45 degrees, and balancing it with that crushing force. And so there needs to be 500 pounds, or there will be 500 pounds, there needs to be 500 pounds of resisting force. So if you had a flexible bundle of pipe that weighed 1,000 pounds and you had it at a 45 degree angle, you can take that and you can fold up that pipe. So you gotta be careful. So it shows all this and how you have to be cautious of that compression load. So when you have a concern about the capacity and compression for your load, like flexible pipe, you should talk to Matt about it, or talk to me about it, or someone, Ben McKinney or Ben Dow. And also, this is a little, it's coincidental that 500 pounds is a crushing load, which is also equal to a 500-pound force on that end, because the tangent of 45 degrees is equal to the sine of 45 degrees. So, because the legs are equal in length. Now here, on the project profile of the week, I made a mistake. Kind of sloppy, I'd say. So this should say the Town of Huntington Paving, but that's last week's title, and I missed it. I didn't get it fixed right. I had the computer reboot. Maybe that's what happened to you this morning. I had a Windows update right in the middle of this, and it forced it to change up. So we contracted with the Town of Huntington for their municipal paving, which included 1.2 miles of their main road to the south end of town, which is almost a Buell-Store road. And the scope work included traffic control, sweeping, grinding, beginning and end joints, grinding of beginning and end joints, application of RS1, 1-inch shim course, and 2-inch overlay, and pretty much 3,000 tons. So quite a big paving project and a quick in and out. So there we are on one of the section of Main Road, and I think I kind of recognize that. That's along the Huntington River, of course, right? Or near it. So looks like a great little, high production, high volume asphalt project, paving project. So, I got one picture. And for the archives, I have a picture of this is the turntable mechanism for the New England Central Railroad. We rebuilt and realigned everything in the mechanics that turns the turntable. The turntable is the locomotives drive on and then onto the track on the middle of the table, and then they can turn the table and send the locomotive off in a different track alignment. So we tore that apart. Basically, what it is a movable bridge, in a sense, just like the swing bridge, like East Alberg. Movable bridges can be either in the horizontal or in the vertical, like a drawbridge. So that's what we got. Thanks. Rodney.
Jerry Johnson. This week, work safe. Maybe switch today. I'll go check my email.